Okay, so we've done quite a bit with this function already. You just watched a 15-minute long video, or maybe you didn't, I don't know, but there was just a 15-minute long video that I did. See, I have the proof. See? Can you guys, yeah, all right. So this, we're just going to graph to check our work. That was probably really, really dizzy, wasn't it? I'm sorry about that. All right, anyway. So we got, first of all, we plugged in 17.3 and got 6.7-ish. So I'm just going to kind of keep track of that. F of 17.3 was más o menos 6.7. That's Spanish for more or less, for all you French majors out there. And then when we found, when we were asked to find x, given f of x was 6.7, we got that x was 9.3 more or less, and 10.7. All right. When f of x equaled just about 6.7. Okay. So let's graph this. Well, the axis is 5, the amplitude is 2, so our range is going to be from 3 to 7. There's the x-axis. Let's draw the axis first of 5. So that would be 7 up here, and this would be 3 down here. All right. Now it's cosine 5. Okay, we have to. We've gone over 10 to the right. Let's just. I know it's not going to be to scale. Let's say 10 is right there, and it's cosine, so it's starting up there. Not much we know so far. Okay. Now we've just got to take into consideration the pi over 4 to find the period. So the period of a function is 2 pi over b, and b in this case is pi over 4. 2 pi over 4 is like 2 pi times 4 over pi. Pi's cancel, we're left with 8. The period is 8 units. So it'll end at 18. Also at a high point, at a maximum, because it is cosine. Okay? Halfway between that, we are at 14, and that's going to be a minimum. Halfway between that, we're at 12, and then 16, and we have points on the axis. Right? So our graph looks like this. All right, it's not bad. That's the way one cycle looks. Now, let's check our work. When we let x be 17.3, we got 6.7. Okay? When x is 17.3, we're somewhere in here. And just by our drawing, I wish I had done this on lined paper. We'd be a lot better off in checking our work. All right? But we see that, all right, y is somewhere in the 6-ish range. You're pretty close. When x is 17.3, you're pretty close to the end here. So yeah, you're up here in the maybe upper 6s. So that's very much probably correct, right? Very much probably. Is that, people don't say that, but I'm gonna start to. I'm gonna use that. Next, when y was 6.7, when y was 6.7, we got 9.3 and 10.7. Let's see. When y is 6.7. So again, you know, that's kind of coincidental how that happened, all right? When y is 6.7, again, we're up here somewhere, maybe. So if we just look down, we see that that's probably this one, right? 10.7 is probably that one. So that's probably accurate, right? That's around where 6.7 happens in the y. 6.7 in the y is up there. So f of theta, f of x in this case is 6.7, and x is about 10 point something. So we're probably right, all right? Now, the 9.3, you're probably realizing, comes from the fact that this function really has a domain of all real numbers. It goes on forever. This is just one cycle. If you go backwards a little bit, so let's say, went back to 8. 8 would be on the axis, right? Just going in order. The next point, I'm going to make this a little bit closer over here, so we have a little bit of a break. And then 8 happens to be on the axis. So that would be more of the function. So yeah, okay, 9.3, an x of 9.3, so right about here, that's that point right there, right? So those are two values we found when we let y be 6.7. So we've done this accurately, okay? Bueno.